Hi, Nicole.
Hi. So yeah, I wanted to talk with someone who works in this space and has more experience with data storage and operations today. So first question is, given the wide range of storage options available today, how do you decide when to use relational databases or data warehouses versus data lakes or specialized platforms for a particular business need?
Yeah, that's a very good question to start with. So when working in under data storage and operations, the choice for storage option mainly comes in depending on what's the end goal, what you're targeting. So the objective that is. So when you go, for instance, with its transactional systems, you go with the RDBMS, the relational database management system,
Mhm.
because this is where integrity is non-negotiable. So you want to ensure that integrity is maintained during that. And with the ACID compliance for RDBMS, that's the best option. And when you're dealing mostly in business intelligence, the BI bit and analytics, a data warehouse is more suited for this because it ensures that the historical data across departmental business intelligence utilize the dimensional model, the well-structured dimensional model. For data lakes, that comes in when the data scientists want to explore the raw data, find patterns, identify patterns, or learn different things from the data. So a data lake will be chosen when you want to ingest that wide range of raw data that you collect from the field or during your operations. Yeah, so for object storage, this is mainly determined by the low cost bit, the cost that you want, or the cost that you have as a business or an organization, because it's highly scalable storage of raw files, logs, and the long term cold backups. When you look at the data lifecycle management, you find that archiving goes well in those cold backups or cold storages. And for specialized platforms, this you basically select them based on the specific data structure that you have at the given time. It might include the temporal databases when you need to build in support by temporal data. I could also mention the NoSQL platforms,
Yes.
which will basically rely on the base type access methods. Yeah.
Yeah, nice. Just to reiterate something I heard from last month's discussion group that we had Michel Herbert, and he was saying how if you have a relational database, it's normalized. And because of that, you're getting some validity guarantees for free, essentially, in terms of when you're bringing the data over to the RDBMS. It's logically structured. So it helps make relational databases such a popular choice for so many underlying systems. So I just wanted to reiterate that for anybody that happened to miss that session with Michelle, because I thought that was like a really good way to explain why the relational scheme and relational databases are so popular. Okay, awesome. So, Eliud, how do you balance performance, scalability, cost, and operational complexity when designing or recommending a storage architecture?
Yeah, we have to understand when we're working in storage that you cannot optimize all this simultaneously. There must be some trade-offs or something that you sacrifice while you are maximizing or optimizing the other. But you basically follow the service level requirements and SLAs, service level agreements, with the different business stakeholders, where you choose a balancing mechanism for the and you use data tiering strategy. We have the high performance, which goes to the hot storage. We have the low performance or data that you don't access regularly, which goes to the warm storage, and the archived data that goes to the cold. And when it comes to scaling, you have to weigh the vertical scaling, which is adding processing power or memory to a single node, against horizontal scaling, sharding or distributing clustering across networks. Also, horizontal scaling gives you massive elasticity, but you must look at it through the lens of a cap theorem.
Can you
Yeah.
say more about that?
For the cap theorem, it states that the distributed system cannot simultaneously comply with perfect consistency, availability, and partition tolerance. The
Okay.
larger your distributed system grows, it means that the more you have to trade off.
So I did an okay job of explaining cap theorem earlier, hopefully. Okay, so Anandi asked about with sharding, is it always horizontal partitioning or can sharding also be vertical partitioning as well? So let me just quickly define sharding for those that maybe haven't read this chapter yet. Sharding is also referred to as database sharding. It's where you typically horizontally partition a large data set into these independent chunks. And the different chunks are typically distributed across multiple servers. So the rationale for doing this, it helps you deal with really large data volumes and also high amounts of traffic. So yeah, the main benefit of this is to overcome single server limitations. kind of answered the question in my definition. But yeah, feel free to jump in.
Yeah, sharding can also be vertical. Remember, for horizontal sharding, we are basically splitting the database by rows. And for vertical sharding, it splits the database by columns or the specific function or tables and distributes this to distinct parts across the completely different physical servers. So it's possible to do it on vertical as well.
Yep. And yeah, when would be a good time to use vertical sharding?
Architects basically choose those vertical sharding to solve specific performance and operational bottlenecks. So it depends on what are you optimizing. If, for instance, it's the input, output, and caching, this is a good time to use the vertical sharding. Or you are targeting security controls. So highly sensitive columns, things with PIIs, credit card tokens, or even identity numbers, things like social security numbers or national identity numbers. Also to reduce write contentions. Yeah,
Right.
those are some of the examples when you choose vertical sharding.
Oh, so are we clear as a group on sharding and how it's usually implemented versus how you could implement it with columns, quote, vertical sharding? Yeah, okay. So, Eliud, can you walk me through an example where a storage or operation decision had a major impact on system reliability, analysis, performance, or business continuity?
Yeah, and even before we go to that, this week I read an article by Sana Sangia about the one big table, and this related to that storage decision, that the issue that I experienced. So where you just start as a temporary table and it just grows and becomes a headache to everyone. So
Yeah.
what happened? Yeah, this happened in an organization I was working with, and the core transaction system started suffering performance degradation. And what we realized is that the database had grown so much that now it had to lock when certain transactions were taking place. This locking affected the write because when you're reading, the write was being affected. And it was a multi-terabyte table, handling both high-frequency live writes and heavy historical analytics. So we needed to improve this. And during peak hours, as I've mentioned, we experienced massive analytical locks where you are trying to write and it can't write. You can't write into the database because someone is performing some analytics. Just to mention, the fix was first we needed to replicate, and this is also mentioned in that article I referred to, and also partitioning the tables.
The second part was partitioning, but what was the first part?
Replication, a
Ah,
database replication. Yeah.
yes. Also a key aspect of the chapter.
Yeah, trying to offload the analytical queries to a read-only replica.
Okay. Yeah,
Yeah.
very cool. Yeah, I think that's a great example. And I'm sure that the one big table is a problem that a lot of organizations ultimately face. And you said it was,
Yeah.
in this case, it was a temporary table or it was a transaction?
No, it was a transactional table in the article I referred to. It started as a temporary table and it grew into that one big table.
Yikes. So, yeah, a couple different ways that you could end up with the same problem. But as you mentioned, the fix here was replication to a read-only table for analytical queries and sharding.
Yes. Yeah, the partition in bit.
Very cool.
Yeah.
So, what are some other important practices for things like backup, disaster recovery, resilience? Where do you think organizations are falling short in those areas?
Most of these backups, disaster recovery, and resilience, they are all to ensure business continuity management. So everything hinges on defining the two clear metrics. What is the recovery point objective, which will dictate the maximum acceptable loss? Yeah, so what can your business tolerate as a loss, especially in the data bit? And recovery time objective. This will define the maximum acceptable downtime. So how long can you stay without access to this data as an organization? And today, where data is a very important asset in the organization, that can't be too long. The most critical of this is implementing automated multi-region backups, where you ensure that your backups are stored in different servers in different locations. Also, try to update these backups based on how technology is changing. Remember, if you archive your data or you back up your data in floppy disks, you can't read them today, or you'll have to experience a very hectic time trying to find a floppy disk reader.
Yeah, it mentions that in the chapter. But if you archive to a storage media, which is then you lose all your readers for that storage media, you're in trouble. It
Yeah.
always makes me chuckle.
Yeah, and most organizations fail on testing backups. Once you create a backup, not all organizations test whether the backup is actually readable. And this poses an issue when you're trying to recover the data. If you can't read the backup, that means the data has been lost. So this is a major failure in most organizations, and pushing that to your organization is a good idea.
What about encrypting backups so that they're not as much of a security risk?
Yeah, encrypting and ensuring that you can recover this or you can decrypt the data. When you are strategizing on the recovery management, the whole business continuity management, you have to ensure that while you encrypt, you also have the decryption keys. You have hardware that can read these backups, or you have tools to read this backup. And you actually test your backups to ensure that you are actually storing something that you can use to recover, not just storing things that at the end of the day they are lost.
All right. How do you approach data lifecycle management, including retention, archiving, tiering, and deletion, especially given that different stakeholders will have different needs?
Yeah, this is a classic data governance challenge. You usually experience this, especially when you're building or setting up data governance. It requires a data retention policy, a formalized one, in the sense that driven by the cross-functional committee. I'll give a quote. Data governance is about doing the right things. I think it's from John Ladley. And data management is about doing things right.
Mm-hmm.
Legal and compliance teams typically want the aggressive data purging, where you minimize the liabilities that come by when you don't purge the data that you're supposed to, especially under frameworks like GDPR. For data scientists, those who have worked in data science, we want to retain all the data because we believe that we can use it down the line somewhere.
Yes.
Yeah, so we want to retain all the raw data forever to train machine learning models, understand our businesses, and the like. I resolve this by mapping out the formal phases of the data lifecycle from creation, active utilization, short-term archiving, and the long-term preservation. And we don't want to forget the final destruction. Yeah, and when data is going through all these phases, you ensure that the long-term preservation, you must account for changes in the underlying technology or structure.
Right. Nice. I see a question. We will save that one. I will address it, sad, but let's keep going with data storage and operations. We might do one or two more questions if that's good for you, Eliud. We talked about how we approach lifecycle management. How about monitoring, alerting, and operational metrics? Which metrics do you rely on to ensure that our storage environment is healthy, secure, and efficient over time?
Yeah, in monitoring and the whole operational metrics, one of the most important ones, and it may seem like a cliche, it's the storage capacity. You need to monitor the storage capacity. If it's the disk space, velocity, table space utilization percentages, and the transaction log headroom. You need to know this at any given time, and your monitoring tool should show you this. Then there is the performance bottlenecks. This is also something you check on the CPU and the memory saturation, the cache hit ratios, and long running queries, and setting alert for that or if a query runs for too long. Then there is the security monitoring, spikes in failed authentications attempts, unauthorized privilege elevations, and unauthorized schema on configuration modifications. This is also important because you want to know who is changing the data. Are they allowed to do that, and what have they changed? And it could also alert you if someone has breached into your data or your storage. I think also data resilience, things like backup verifications, as I mentioned earlier. You want to measure the success rate of your backup verification, point in time recovery, log health, and replication lag times across high availability clusters. If you are recovery or you need that comprehensive operational dashboard that covers all this.
Yeah, having a dashboard, that's a great piece of advice.
Yeah.
Okay, so to wrap up with this section, do you have any tips for the folks in the audience around how to prepare for the data storage and operations chapter?
Yeah, so look through the various storage choices, how you make the choice. And someone mentioned about the terms. Try to understand these terms, as I know they are quite hard. Yeah, the abbreviations and the acronyms. Try to go through that, and because they form an important part on both the examination and understanding the whole concept of this. And when it comes now to the industry application, so you want to ensure that you understand both, especially I think it was the second question, the one for where you balance performance, scalability, cost, and complexity, and try to see which one do you want to prioritize in your organization when you are doing this, because if you can't do all four, you have to choose them based on what your organization is aiming for. The next bit is things are changing and the future, especially today with cloud and the like, and that also affects how the storage choice that you make.
Great. All right. Thanks for the wrap up. Really appreciate your time as our SME, Eliud. This was very helpful. Hopefully, people have a better feeling of fluency with this chapter. And yeah, thank you guys so much for joining. And if you do think of any more questions for myself or for our SME, who very kindly joined us today, so thank you again, Eliud, feel free to reach out. Eliud, do you like to have people connect with you on LinkedIn? If so, feel free to drop your LinkedIn in the
Yes.
chat. But yeah, feel free to reach out to us at any time. We're always happy to help support. Thanks again, Eliud. Really appreciate your time today, and I hope everybody has a great day. Bye, everybody.